Hello everybody, welcome to the video. Today we're going to be going over what's called the law of cosines, and just like the law of sines, the law of cosines is used to find the missing segments and angles of a triangle. So this is what the law of cosines says. Notice that the first part of the law of cosines looks an awful lot like the Pythagorean theorem, right? A squared plus b squared is c squared, but then you have this minus 2ab cosine of c expression. So this basically takes into account the fact that we're dealing with an acute or obtuse triangle. If it was just a right triangle, it would be a squared plus b squared equals c squared. But this is sort of the general Pythagorean theorem right here. So what I want to do in this video is show you how to use these equations to solve missing side lengths and angles, and I also want to show you the proof of why this equation works. So if you just want to see the examples, you can take a look at the description of the video and click on the timestamps. But the first thing I want to go over is why this thing works. So this is the proof of the law of cosines. Here, notice we have a triangle ABC, and the segments across from the angles are also called ABC with lowercase. The first thing we're going to do is drop a perpendicular line from C to AB right here. We're also going to call this distance from A to H x, which means that this distance from here to B is c minus x, because x plus c minus x would be c. From this triangle, and with the Pythagorean theorem, we know that x squared plus h squared is equal to b squared. Let's call that equation 1. We also know that the cosine of a is equal to the adjacent side, which is x, over the hypotenuse, which is b. If we multiply both sides by b, we get b times the cosine of a is equal to x. Let's call that equation 2. Now, from this triangle on the right-hand side, we know that c minus x quantity squared plus h squared is equal to a squared. That's based on the Pythagorean theorem. If we expand c minus x squared with an area model, kind of like I did right here, we realize that c minus x quantity squared is equal to c squared minus 2cx plus x squared. Here I just flipped the equation. Now notice that we have an x squared plus h squared right here in our equation. And based on equation 1, we know that x squared plus h squared is actually equal to b squared. So let's substitute. Here I just did some rearranging. I put b squared first, c squared goes right here, and minus 2cx goes right here. And I want you to pay particular attention to this x right here. Now, based on equation 2, we know that x is equal to b times the cosine of a. So let's substitute that, and then you have your law of cosines right there. And this also works for any other side length b and c as well. So this is the proof of the law of cosines. Now let's go over an example of how to use this thing. So I will say that for using the law of cosines, it's going to be mostly calculator work, and it's going to be a big expression that you have to type into the calculator. So here we have the different versions of the law of cosines, which you should be aware of. And in this example 1, we're going to solve the triangle. So we know what little c is, it's 27 centimeters. We know what little a is, 26 centimeters. And we know what b is, 82 degrees. So the question is, what is big A, what is big C, and what is little b? So this is a situation of side, angle, side. And what we need to do first is figure out what the side is opposite to the given angle. Okay? So in order to do that, first of all, we can label our side lengths just like this. And then we use the law of cosines. So like I mentioned, we want to figure out what b is, so we have to use this middle equation right here. Notice I plugged in a for 26 and c for 27. And 82 for b. So I use this middle equation right over here. Then basically what you do is you plug this whole thing into your calculator. And I've included my work here that I did on my calculator, so you can type it in to make sure that you get the same thing. I would also want to remind you that make sure your calculator is in degrees mode, not radians. So you should get 1,289 is approximately equal to b squared. So then in order to solve for b, what you have to do is take the square root of both sides, like you see right here. And the square root of the answer that we got is about 34.8 centimeters. So let's label it right here in our picture. Okay, so now we know what b is. We know what little b is. It's 34.8 centimeters, and we got that using the law of cosines. So now what we're going to do is figure out what the angles A and C are, and we can do that using the law of sines. So if you remember from my video for the law of sines, you set it up by writing the sine of A is equal to the opposite side, the sine of A over the opposite side, 26, right here, is equal to the sine of 82 over the opposite side, 34.8. So that's the setup for the law of sines. Cross multiply. Divide both sides by 34.8 to get the sine of A by itself. Cross things out. And we realize that the sine of A is equal to this expression, which I've typed into my calculator, and I realized it's 0.7399. So if we know that the sine of A is equal to that decimal, what we can do to figure out what A is use inverse trigonometry. So once again, if we know that the sine of A is equal to a number, that means that A is equal to the inverse sine of that number. So you punch that into the calculator, and you get 47.77 is your answer for A. So I would imagine the biggest difficulty you probably have with this is plugging it into the calculator. So if you need help with that calculator work, you can just let me know and I can help you out with that. So let's plug it into our triangle. We have 47.7 right over here. Okay, so since we know two angles of a triangle, we can figure out the third one using the triangle sum theorem, as you see right here. So the measure of angle C is equal to 180 minus 82 minus 47.7, which equals 50.3. Let's label that in the triangle, and then you're good to go. We've solved the triangle. So this is how to use the law of cosines in order to solve a triangle in the situation of side, angle, side. Okay. In the next example, you're going to be given the three side lengths of a triangle. So side, side, side. So what I have here is the law of cosines written again, but this is another version of the law of cosines. This is, for example, here in red, this is where A is by itself. So if we subtract like b squared and c squared from both sides, we get this numerator, and then divide by negative 2bc, you get it in the denominator, and then use the inverse cosine to get A by itself. So the point of these equations is just a nice little shortcut to be able to determine what an angle is based on the side lengths. So I would recommend writing these formulas down. They're pretty much the same as these, just written in a different way, and they're written in a way that you can easily figure out what the angles are. So let's put that to practice in the next example. Okay, so example 2 here, we're going to solve the triangle, and as you can see, this is an example of side, side, side. So this is the equation that I had on my previous slide that we're going to use. This is the law of cosines. It's just another version of it. So what we're going to do actually is first of all label our side lengths, little a, little b, and little c, and apply the formula. So little a would be 17, little b would be 19, and little c would be 21. So all you really need to do is to plug this into your calculator, and then you're going to be able to figure out what little a is. So don't be intimidated by this big formula. I know it looks like a lot of variables and stuff, but you just pretty much have to know how to plug it into your calculator and you're good to go. So this is how to do that. It's going to be the inverse cosine of all this right here. And if you plug that into your calculator, you should get this number, which is about 50. So once again, if you're struggling figuring out how to get 50 based on this, if you're not quite sure how to plug it into your calculator, you can definitely let me know and I can help you with that. But here we learned that A is approximately 50 degrees. So let's put that in the triangle. Okay, so we can use the law of cosines again to find another angle, like for C, for example. We can do that. The way I'm going to do it, though, is I'm actually going to use the law of sines. This is what we learned in the last lesson. So here, since we know that A is 50 degrees, I'm going to write down that the sine of 50 over 17 is equal to the sine of C over 21. And then what you're going to do is cross multiply and solve for C. So here we cross multiply. 17 times the sine of C is equal to 21 times the sine of 50. We divide both sides by 17. Cross out the 17s. And realize that the sine of C is equal to this expression. So then what we're going to do is realize that the angle C is equal to the inverse sine of that expression, because that's how you find angles with inverse trigonometry. So now it's just a matter of typing this into the calculator. So here I took a screenshot of my calculator. So the sine to the -1 of 21 times the sine of 50 over 17 is about 71.1. So let's go ahead and put that in our triangle. Now, because you know the two angles of a triangle, that means that you can figure out the third one by using the triangle sum theorem. So the measure of angle B is equal to 180 minus 50 minus 71.1, which is about 78.9. So let's put that in the triangle, and then you're good to go because you figured out all the side lengths and all the triangles of this, all the side lengths and all the angles of this triangle. And that's how to use the law of cosines to solve triangles.